Yeah, you can see here the difference between a concave and convex mirror. May I know the differences between the concave and convex mirror from your side? Say, no, what is the first point in case of concave mirror? It's made by a silvering the outer surface. Silvering means what? Reflecting surface. Is it right? Yes, the difference between a concave and convex mirror.
Yes, sir.
Yes, sir.
Concave and convex mirror. I'm getting resound actually. I don't know. Look at the second point. It is made up of silvering the inner surface. Inner surface means inside surface is a reflecting surface or outside surface is the reflecting surface of the hollow sphere. So the reflection takes place from the bulging surface. Bulging means bent. Is it right? Here the bulging surface is there. No. Surface of a part of the hollow sphere, so the reflection takes place here is directly. Silvering means the coating with paint, means painted with what we call coating with paint actually. So if you see the surface, here it is. Outer surface is silvering, means what? Painted with some what we call some color. And inside surface is reflecting surface here for concave mirror. Here it is made up of by a silvering the inner surface. Inner surface means if you see like this, inner surface is coated with some paint. Okay, inner surface is coated with some paint here, and whereas outer surface is bulged, means bent. This is what we call reflecting surface. So there is a chance to ask the difference between the concave and convex mirror or concave and convex lens for 2 marks question. So at least you have to write 2 to 3 points for each. So it converges the light rays incident on its reflecting surface. Means what we call, we know very well as we have discussed in the previous session. It is our concave mirror. When any light rays incident on the mirror, which are parallel to principal axis, they converge at which point?
Focus.
Focus.
Yes.
So simply we know that it is it is bent inward, then the light rays when incident on the surface, they converge at point. Means we can say that this mirror is a converging mirror. Is it right? What type of mirror it is?
Converging mirror.
Converging mirror. So and what about the convex mirror?
Diverging source.
Diverging mirror. Is it right? So it's diverges the light rays incident on its after reflection. So you can see here, simply if you draw a mirror, when any light rays incident on this surface, after incidenting means after reflection from this surface. So it is the incident ray. We know that when any light rays coming parallel to principal axis, they reflect through focus. Is it right? But for this, the focus is behind the mirror, so it will goes like this. If you draw one more light rays which is coming parallel to principal axis, and it will reflect along the what we call focus, which is appearing, which is coming from the focus here. So are the light rays are converging or diverging both? Yes, sir, no? Diverging. No. So the light rays will diverge here on the reflecting surface of convex mirror. Is it right? So we call it as it is a diverging mirror and it is a converging mirror. Any other differences for both? Any other differences?
Sir, its application.
Yeah, its applications we can write. But convex mirror gives a real image and as well as virtual image. Real image when object is placed beyond C, at C, between C and F. Is it right? First 3 cases. Always real means which is in front of the mirror here. And as well as we'll get behind the mirror also in case number 5. Is it right? When object is placed between F and P. But whereas convex mirror gives always which type of image?
Virtual image.
Only virtual image. Is it right? Only virtual. The image found by it's always virtual for all position of the object. Here, no matter where you stand in front of the mirror, but always will get virtual image only. Is it right? So here object image always will get between C and between P and F. Is it right? Diminished and virtual image always. So these are the main differences between these two. And you can say this mirror is used somewhere applications, one or two applications. This mirror also used at some of one or two applications. Okay. And those are the main differences between these two mirrors. Now look at here, distinction between plane mirror, convex mirror and concave mirror. Before that, you see here, first of all, case 1. If the image is upright of the same size and it does not change its size by moving the mirror towards or away from the object, which type of mirror is this?
Convex mirror.
Convex mirror, sir.
Is it same size of object and image in convex mirror?
No, sir.
No.
Plain.
Very good. It is a plane mirror, is it right? See, image is upright, same size, and it does not change its size. So in case of convex mirror, the object and image sizes are not same. But in case of plane mirror, both are same. Is it right? So the answer is plane mirror. You can see here, what is this?
Candle.
Candle.
We used to call object, is it right?
Yes, sir.
Yes, sir.
Now, if you change the position of the object, is there any change in position of image, like size of the image?
No, sir.
No change in the size of the image. Is it right? So we can say that it is a plane mirror. If there is a change in size of the image, then we'll think about that whether it is a spherical mirror or what we call convex or concave mirror. But there is no change in the size of the image. It means it is a plane mirror only. Is it right? Now you can see here, if the image is upright and the magnified, what is the property? What are the properties of image? Image is
Upright and magnified.
and increases in size on moving the mirror away. Okay, then which type of mirror is this?
Convex, sir.
Concave.
Concave.
Concave or convex? See,
Concave.
magnified is not possible in which mirror?
Convex.
Convex. Yeah,
Convex.
in convex mirror, magnified is not possible. So it is a concave mirror only. Is it right? So you can see here,
Yes, sir.
what type of mirror it is?
Concave.
Concave mirror. So you can see here clearly the reflecting surface is bent inward or outward?
Inward.
Inward only, Nana. The reflecting surface is bent inward. Is it right?
Yes, sir.
So it is a concave mirror. Now, one more case. If the image is upright and diminished
Convex.
Convex.
and
Convex.
decreases in size on the moving the mirror away. So here not increasing, it is decreasing.
Convex, sir.
Yeah, it is convex mirror. Is it right? So three types of mirrors. So it is a convex mirror. So where we can see this convex mirror?
In what we'll say now, mainly in forest areas, sir. Means like
Sir, parking
Everywhere.
spots.
in parking lots.
Yeah, at
Parking
parking
lots.
lots. Yeah, at parking
Sir,
places.
rear view mirror.
Yeah,
Security
rear view
purposes
mirror.
of parking.
Very good. Now you can see here that actually the electric tower is too big, but it appears in very small inside the mirror. Is it right?
Yes, sir.
So it is a property of the mirror to show the diminished image of any object. Is it right? Now we'll see the criterion of sign conventions. Means Cartesian coordinates, you know, basically from our math side, Cartesian coordinates and normal coordinates. See, who is this? Descartes, sir.
Yes, sir.
So Cartesian coordinates invented by this Descartes only, Nana, to show that the coordinates of x-axis and y-axis here, what we call them Cartesian coordinates. This is a plane surface of what we call x-axis and y-axis. You can see the coordinates here, x coordinate and y coordinate. So this is a very, very, very important point here. You have to note down. Look at here, x-axis and y-axis. Okay, this is plus. Okay, plus 1, 2, 3, 4, 5. You know very well. And this is minus side, minus 1, 2, 3, 4, 5. Okay, and here again it is plus y-axis, plus 1, 2, 3, 4, 5, and so on. And this is minus y-axis, minus 1, 2, 3, 4, 5. Is it right? And so on. So these coordinates are very, very important to understand that which one is positive. Object distance is positive or image distance is positive, or object distance is negative or image distance is negative. Okay. Now let me remove those points. We don't want those points. We want the axis, which one is positive and which one is negative. So what we call this point is known as
Origin.
origin. Yeah, very good. No, origin. Is it right? Now, what type of mirror it is?
Concave.
Concave.
Concave. See, in front of the concave, which symbol is there?
Minus.
Minus.
In this Cartesian coordinate, if you see towards upward, means along the x-axis or y-axis, this arrow marks indicates
Y-axis.
y-axis. What is the symbol is there?
Plus.
Plus. And towards x-axis, this distance, which symbol is there?
Minus.
So remember, these 2 points are very, very important. Okay, keep it in mind. Now, first point, behind the mirror, like we call it as F1 and F2 or C1 and C2, what we call F1, C1, and in front of the mirror, F2, C2. Any point we can represent. And simply, these are mirrors, so no need to say this is F1, F2, F3, some and so on. Simply write it as F and this is C. Okay, in simple words. Behind, no need. For concave mirror. For lenses, it is very important. Now look at here. First situation. Object AB, is it right? Where it is placed exactly now?
Between C and F.
Between C and F. Yeah, very good, Nana. Now, if you object should be always to the left of the mirror. To the left of the mirror means in front of the mirror. Is it right?
Yes, sir.
Now the distance of object, basically from where we will measure?
From pole.
Pole. Is it right? So this is not correct image. This is in case of lens here. Don't focus on that. We'll measure all the distance from the pole. Now look at here along the x-axis. What is the symbol here?
Minus.
So what about the object distance? Is it plus or minus always?
Minus.
Always minus.
Object distance is minus. Now look at the object height. Object height. Along the x-axis or y-axis it is?
Y-axis.
Y-axis.
Is it positive or negative?
Positive, sir.
So object height is HO is positive. And object distance U is
Negative.
negative. Is it clear now? How we
Yes,
get
sir.
negative and positive? In simple words, Nana, these are. Okay. So you don't think about this image position here. Why? Because we are not talking about the position of the object and position of the image, but the situation here, how the image appears. If you see the distance of image, if it is this side, okay, is it positive or negative? Distance of image.
Positive, sir. Positive.
And look at here, it is inverted here, is it right? The height of the image along negative y-axis. Height of the image is positive or negative?
Negative, sir.
Negative, sir.
Is it right? So always remember, whenever you will get this object position and image position, whether it is positive or negative, simply imagine with your x-axis and y-axis, Cartesian coordinate. Okay, so that you will get clear idea which one is positive and which one is negative here. Okay, so no need to note down these points. You can simply read these points. This distance is negative distance, so image height is negative. You can see here. What about the focal length then? Focal length is positive or negative?
Negative.
Focal length is always negative. Why? Because it is along the negative x-axis. Is it right?
Yes, sir.
For concave mirror. For convex, again, it is always positive. Okay, keep it in mind. The focal length of the concave mirror is negative, and focal length of the convex mirror is, why it is positive for convex mirror? Why? Because convex mirror is like this. So focal length behind the mirror along the positive x-axis. Is it right?
Yes, sir.
That's why it is positive, Nana. You can see here. This is along the positive x-axis. So the focal length of the mirror is positive for convex mirror and negative for concave mirror. While solving the problems, these are very, very important, Nana. So mirror formula. Do you know what is mirror formula?
Yes, sir.
What V indicates?
Image distance.
What U indicates?
Object distance.
What F indicates?
Focal length.
Focal or focal length. Very good. So you can see the formula where V is image distance, U is object distance, F is focal length. The formula is 1 by V plus 1 by U is equal to 1 by F. Is it right? And magnification formula. What is the magnification formula?
M is equal
HI by
to
HO.
by U.
E by U, sir.
Yeah, size of the image, HI by size of the
HO.
object, HO. Is it right? Or minus image distance by object distance. Is it right? Image distance
Yes,
by
sir.
object distance, negative. Now we'll see the problems based on this mirror formula. Okay, at least 1 or 2 problems. You can see the mirror formula here directly, or you can take the screenshot of it. Okay. Problems based on this mirror formula we'll discuss now, at least 4 to 5 problems. Always remember what you have to remember here. U is always
Negative.
negative. Keep it in mind. F is always
Positive.
for
Positive.
which mirror?
Convex.
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 Convex. F is always
Negative.
Negative.
for
Concave mirror.
concave mirror. These points are very, very important. These are always. Not by changing the position of the object or changing the position of the what we call mirror image. But these are the always constant. Object distance is always negative, and focal length positive for convex and focal length negative for concave.
Image distance, sir.
Image distance is changing, but that depends on the position of the image, position of the object in front of the mirror. Okay. Now read the question number 1. An object is placed at a distance of 36 centimeter from the concave mirror. Which type of mirror is given?
Concave mirror.
Concave mirror. Of focal length 12 centimeter. Find the image distance. Okay. Find the image distance clearly asked here. So first, our step is to write the given data. Which type of mirror it is?
Concave mirror, sir.
Concave mirror. Okay. Then object is placed somewhere. Okay. We don't know the object distance. Now we have to calculate that object distance. So to calculate the object distance in front of the mirror, the position of the object, check with the focal length. What is the focal length of the mirror? Focal length of the mirror is 12 centimeter. Is it right? Then what about the radius of curvature?
24 centimeters.
24. Object distance is how much?
36.
36. It means beyond C or between C and F or at C?
Beyond C.
Beyond.
36 is more than 24. So object is always beyond C only. Is it right? So you can see here, this is 36 centimeters. This is 12 centimeters. Focal length is 12 centimeters. Then image where we will get, Nana, as per our what we call knowledge of case
In C and F.
between C and F. Without calculating, we can say that. But our task is to find the image distance by using which formula?
Mirror formula.
Mirror formula.
Is it right? So first, our task is to identify the value of position of the image in front of the mirror. So we have identified. Now task is to find the value, V value. Okay. F value, you know that. Object distance, how much it is?
36 centimeters.
Is it positive or negative?
Negative.
U is equal to minus 36 centimeters. Don't ask again, sir, why negative came here. You know why it is negative?
Sir, why? Because it's a concave mirror, so the negative.
No. For concave or convex, object distance is always negative. Why? If you see here, if you take the y-axis here, along the x-axis, which x-axis it is? Positive x-axis or negative x-axis?
Negative.
X-axis.
So negative x-axis. So object distance is always negative. Is it right? As per our Cartesian coordinate. Now focal length. Focal length is negative or positive here?
Negative.
It is
For concave mirror, always negative. Is it right? Again,
Yes.
it is along the negative x-axis. Now image distance. Image distance is to find here. So question mark. So use the formula 1 by v plus 1 by u is equal to 1 by f. Okay. That is mirror formula. Simply substitute the values of u and f here. Okay. Then you will get the answer. So simply send this 1 by u that side. Then 1 by f minus 1 by u. What is the value of f?
minus 12.
Minus 12. So it is 1 by minus 12 minus. And what is the value of u?
Minus
Minus 30.
minus
Minus 36.
So 1 by minus 36. Minus into minus is
So,
plus. Is it right?
Yes.
So
Yes.
that equal to 1 by minus 12 or minus 1 by 12. Both are right. Minus into minus is plus.
Plus
Then
1 by 36.
36. What is the LCM of 12 and 36?
36.
36. 36. 12 3 times 36 are?
minus 3 plus 1 by 36.
So simply what we can write here, LCM is 36. 12 3 times is 36. 3 into minus 1 is minus 3. 1 into 36 is 36. So 1 into here LCM is 36. So the numerator value will get 1 only, 1 time of 36. Okay. So minus 3 plus 1 is how much?
Minus
Minus 2.
Minus 2. So 1 by v is equal to minus 2 by 36.
36.
Is it right? Then v is equal to
36 by minus 2.
yeah 36 by minus 2. So we can cancel here 1 by 18 will get 2 ones are 2 18 times. Is it right? So v is equal to how much?
minus 18.
Minus 18
Minus 18.
centimeter.
Is it greater than minus 12 or less than minus? Means in terms of value without sign, is it greater than 12 or less than 12?
Greater than.
Greater than 12.
Is it greater than 24 or less than 24?
Less
Less
than
than
24.
Less
Yeah,
than.
it means it is in between C and F. Is it right?
Yes, sir.
It means our answer is right. So the image is formed at a distance of 18 centimeter in front of the mirror. Is it easy to calculate now?
Yes,
Yes, sir.
So very easy answer, Nana. Can you do this problem number 2? First our step is to identify the given data. A type of mirror. Which type of mirror is given here?
Concave mirror.
Concave mirror. Very good, Nana. So our step is to draw first concave mirror. Is it right? So what is the focal length which is given in the question?
10 centimeters.
10 centimeters.
Is it positive or negative?
Negative.
Positive.
Negative.
Negative.
Very negative, Nana, not positive. It is along the negative x-axis. Is it right?
Yes, sir.
So negative f. Then what is given here?
Image distance.
Distance is given.
Image distance is given. What is the value of image distance?
20 centimeters.
20
Is
centimeters.
it positive or negative?
Negative.
See, behind the mirror, they said.
Huh.
Behind the mirror means this side. Is it right?
Yes, sir.
So the distance of object is not given, but distance of
Image is given.
Image
image
is
is
given.
given. So you have to strike in your mind. It has to, you have to think about this, where we should keep the objects so that we can get the image behind the mirror. In case of concave mirror,
Between pole and focus.
between pole and focus. Is it right? So can you guess what should be the range of the object distance?
So
Range of-
between 0 to 10 centimeters.
Excellent answer, dear. Between 0 to 10 centimeters only. Now, our question is to check that one. Is it right?
Yes, sir.
We know the answer, but not exact answer. We know the range of the object distance. So here, at what distance from a concave mirror of focal length 10 centimeters should an object be placed so that the image formed is 20 centimeter behind the mirror? So which formula we have to use here?
Mirror formula.
Mirror
right?
formula one.
So first of all, keep the object in between the F and P with a random distance. Assume that object distance is what we'll represent with U. Is it right?
Yes, sir.
So U is question mark here. So focal length is given minus 10 centimeter. Don't ask again, sir, why minus came here? You know that according to Cartesian coordinate, sign rules, sign conventions we know. And image distance is V. It is plus or minus?
Plus.
Yes, sir.
Plus. Why? Because
Sir,
it
why?
is along,
Because in it
along
is
plus
there in a
axis.
positive side, no, sir.
Yeah,
Sir,
very
it
good.
is
Nandini.
going the same direction as the principal axis.
As the incident ray is it right? Along the incident ray direction, it is positive as per our sign rules. Now, focal length is there, V is there, image distance is there. So, to find object distance, U is equal to question mark. Simply write the formula. Formula is 1 by F is equal to 1 by V plus 1 by U. And simply send this image value that side now, not object. Why? Because object distance to find here. So, 1 by U is equal to 1 by F minus 1 by V. Is it right? Now simply substitute the value of F and V here. So F is how much? Minus 10 minus 1 by V is how much? 1 by 20. So what is the LCM of 10 comma 20?
20.
20 is the LCM. Very good. Now simply write that value here. 1 by U is equal to, how many times of 10 is equal to 20?
2, sir.
2 times. So minus 2 will get, is it right? So minus 2 minus 1 by 20. So what is the value here in the numerator? Minus 2 minus 1 is?
Minus 3.
Minus 3. So 1 by U is equal to minus 3 by 20. So if you reverse it,
Minus 20 by 3.
minus 20 by 3. Is it right? Then U is equal to how much? 6.67
6.67
centimeters.
centimeters.
It is minus. Minus indicates what?
Concave.
Towards.
Yes.
No, we are not. This is not image distance. Is it right?
Okay, yes, sir.
Yes, sir.
Towards negative x-axis. Is it right? Minus here. So object distance is 6.67 centimeters from the pole. So the object is placed at a distance of 6.67 centimeters in front of the concave mirror. Question number 3. Can you read the question, please? So what is our first step to do in this question?
You write the given data.
Write the given data and we have to identify which type of mirror.
Mirror it is.
Which type of mirror is given here now?
Convex.
Convex mirror, sir.
Convex mirror. So simply draw the convex mirror. Is it right? First step you have to do is this one only in the exam. By reading the question only, identify the type of mirror and draw that mirror. Okay. And what is given in that?
Object
Object distance. What is the object distance?
20 centimeters, sir.
In front of the convex mirror, 20 centimeters, and found to have an image 15 centimeter behind the mirror. Okay. So then find the focal length. Simply object distance is given. Object distance is positive or negative?
Positive.
Negative.
Object distance is negative. Is it right? So here it is our y-axis. Object distance is always in front of the mirror. So this is along negative x-axis. Is it right?
Yes, sir.
Image is behind the mirror this side. Positive x-axis. So image distance is positive or negative?
Positive.
Positive.
Object distance is positive or negative?
Negative.
Distance negative.
So that is enough. That is enough. Automatically we will get the focal length. Okay. Simply write the given data of object distance and image distance. Object distance is 20 centimeters and image distance somewhere here between P and F, that is 15 centimeter. So note down those two values. Object distance U is equal to minus 20 centimeters. Okay. And image distance V is equal to plus 15 centimeters. And here it is focal length is the question mark. To find focal length F is equal to question mark. The formula is 1 by F is equal to 1 by V plus 1 by U. So question mark is focal length only. So simply substitute these two values here. 1 by 15 plus 1 by minus 20 is equal to 1 by f. Is it right? So what is the LCM of 15 comma 20?
60.
60 is the
Yes,
LCM.
sir.
How many times of 15 is equal to 60?
4 times.
4 times. How many times of 20 is equal to 60?
3.
3
times.
times.
So
Times.
here it is plus 4 minus 3. Is it right? 1 by 15 minus 1 by 20, that equal to 1 by f. Then here it is plus 4 minus 3. 4 times of 15 minus 3 times of 20 by 60 is
Sir,
equal to,
60
yeah,
focal length.
what is the value of focal length?
60.
60 only. Yeah, very good answer. 4 minus 3 is 1. So 1 by 60. So 1 by f is equal to 1 by 60. So no negative here, only positive. So f is equal to how much? 60
60 centimeters.
centimeters. Is it right? Very good answer.
Yes.
So the value of focal length of the mirror is 60 centimeters. Okay. Now look at the next question. An image is formed at what distance?
5 centimeters behind a convex mirror.
Behind the convex mirror of focal length.
10 centimeters.
At what distance is the object placed from the mirror? So what he is asking in the question?
To find object distance.
To find the object distance. But what is our first step to identify in this question?
Which type of
Which
mirror?
type of mirror it is?
Which type of mirror it is? Is it right? Simply draw the type of mirror. Which type of mirror it is?
Convex, sir.
Convex mirror. So object distance we have to find here. Image distance already given. Image is formed at a distance of 5 centimeter and focal length is 10. Is it right? So here it is image distance. Is it positive or negative now?
Positive.
Positive, sir.
Positive. Very good. Why it is positive?
It is behind
It
the
is there in x-axis, no, sir.
Yeah, it is along the positive x-axis in simple words, and it is behind the mirror as per our sign convention rules. So here
Yes.
it is positive x-axis and this is y-axis. Wherever the pole is there, there only we have to draw the y-axis. Okay, so that we can understand easily. So it is along the positive x-axis and this side is negative. Is it right?
Yes, sir.
Now focal length is also given. Focal length is 10 centimeter. Is it positive or negative?
Negative, sir.
Focal length.
Positive.
Positive, sir.
Positive.
Yeah, focal length is positive. Why? Because it is along the positive x-axis.
Yes.
Okay. Now object distance is negative here. Is it right?
Yes, sir.
So simply look at the object distance. That is question mark.
We
Image
have
distance.
to.
Image distance is 5 centimeters. Object distance, focal length is 10 centimeter. Simply substitute in that formula to find object distance. U is equal to question mark. And then substitute in this formula. What is the formula? 1 by f is equal to 1 by v plus 1 by u. So question mark is for u. So simply send this 1 by v that side. Then 1 by u is equal to 1 by f minus
1 by V.
1 by u.
v. Okay. Then substitute the value of f and v here. 1 by u is equal to 1 by 10. F is 10. Minus v is how much?
5.
5. So 1 by 5. Is it right? So what is the LCM of 10 comma 5?
10.
10 is the LCM. How many times of 10 is equal to 10?
1.
So
One
it
time.
is
So
minus 10.
no, it's not minus 10.
She's saying answer, sir.
Acha, answer. Okay. Very good, Amma. We'll see here. So 10 ones are 10. So 1 time of 10 is 10 here. So LCM is 10 here. 1 times. How many times of 5 is 10?
2 times.
So 2 here. 1 minus 2 by 10. 1 minus 2 by 10 is the answer here. So 1 minus 2 is minus 1. So u is equal to 1 by u is equal to minus 1 by 10. Then u is equal to how much?
Minus 10.
Minus 10. Okay. So the
Minus
object is
10
placed in
centimeter.
front of the convex mirror at a distance of 10 centimeter. So answer is minus 10 here. Is it right? So we have to write this point after solving the problem. Okay. Don't say minus 10 centimeters. So distance is always not negative. Okay. Distance is not negative, but sign indicates opposite direction. Negative sign indicates opposite direction. That's it. Okay. So I think this question is over. Now look at the question number 5. What type, which type of mirror is given here?
Convex mirror.
Convex mirror, sir.
Convex mirror. Is it right? So simply draw the convex mirror. An object is placed at a distance of how much distance?
Centimeters.
10 centimeters.
15 centimeters.
From the convex mirror, 10 centimeter is the object distance. What is the focal length?
15
In
centimeters.
centimeters.
Then find the
15
position and
centimeters.
nature of the image. Position, nature. Position is what? What is the position of the image?
Age distance.
Between P and F.
Between P and F. Is it right?
Yes, sir.
What are the nature of the image? Nature means properties.
Virtual, diminished, upright, and erect.
Erect and
Yeah, virtual and erect, diminished and upright. Is it right? Excellent answer, dear. That's enough. No need to calculate actually here. Did he ask what is the distance of the image?
sir.
He didn't ask the distance image. Is it right? So no need to calculate. He asked the position. Position is between
P and F.
P and F. So no need to calculate the distance, as he didn't ask. If you are interested to calculate, you can. Okay. So simply,
Concave, we have to know.
yeah, in concave we have to. Okay. Why? Because that depends on the position of the object. So if you want to find, this is the formula. Substitute in that formula, automatically you will get your value. Okay. I'm not going to explain this again. So simply so can you guess what is the range of the image distance?
30 centimeters, sir.
Range.
Sir, between 0 to 10 centimeters.
Between,
0 to 15 centimeters.
yeah, focal length is 15. So it is greater than 0 and less than 15. So between 0 to 15. Is it right?
Sir.
So if your value is more than 15 or less than 0, that is wrong. If your value is between 0 and 15, that is right. Okay. So keep it in mind, that value. So LCM of 15, 10 is 30. So you have no without LCM here. Okay. No problem. You can do cross multiplication also. You will get the same answer. So answer is 6. Is it in between 0, 15?
Yes, sir.
So your answer is right. And the nature of the image is
Positive.
virtual and erect, or upright
and
and diminished. Okay. Now the last question, and I will stop the class here after this problem. Okay, as we are running out of time. An arrow is placed, arrow means object, okay, at a distance of 25 centimeter from the diverging mirror. Which mirror is the diverging mirror?
Convex.
Convex,
mirror,
sir.
Convex mirror. We are not talking about lens here. We are talking about mirror. So convex mirror. Is it right? Our focal length is how much?
20 centimeters.
20 centimeters.
Find the image distance. Is it right?
Yes, sir.
So try and say the answer. Is it right or wrong? What is the first step?
Identify the mirror.
Identify the mirror, which is given clearly. So use mirror formula. 1 by F is equal to what? 1 by V plus
Plus 1 by U.
1 by U. Yeah. What is given in this question? Focal length is given. Focal length is positive or negative for convex mirror?
Positive.
Positive.
Positive, sir.
Yeah, very good. Now, F is positive. So F is 20 plus 20. And what is given next is object distance is given. Object distance is negative or positive?
Negative.
Negative, sir.
U is negative. Very good. Minus negative. That is 25. Substitute here. Then V is equal to 1 by V is equal to 1 by F minus 1 by U. Is it right? So simply send this 1 by U that side. It will become minus 1 by F minus 1 by U. Substitute the value here. 1 by F is how much? 20. Minus 1 by U is how much? Minus 25. What is the LCM of 20 and 25?
Sir, 100.
100. Very good.
Sir, it's correct. 11.1.
Yeah, very good. Now LCM of 20 and 25 is 100. How many times of 20 is equal to
5
100?
times, sir.
5.
5 times.
5 times, sir.
Minus. Minus into minus is what?
Plus.
Plus
plus. How many times of 25 is 100?
4 times.
4 times. That equal to here 9 by 100. That is 1 by V, Nana. 1 by V, 1 by V. Then V value is how much?
100 by 9.
100 by 9. Is it right? Now simply 9 tens are
9,
90. 9 11 times.
99.
So
20, sir.
11 times 99. So remainder is 1. 1 is not divisible. Take decimal. Remainder is then 10. 9 ones are
9.
9. Again 1 reminder. And 1 1 1 1 you will get. Is it right? 1
Yes,
bar.
yes.
So 11.1 centimeter is the right answer. Is it right?
Yes,
Well,
sir.
let me stop the class here for today.